This is my workbench and this is where I usually go to work on my drones. For me to be able to build my drones, I needed to learn how to solder. But really, what is soldering? Well, soldering is the process of joining two or more electronic parts together by melting solder around the connection. Solder is a metal alloy usually composed of a combination of tin and lead which has a melting point at around 190 degrees Celsius. When the solder is heated to its melting point and it cools back to its original state, or to its solid state, it creates a strong electrical bond. We can use our understanding of basic concepts in chemistry to understand and tackle interferences we may encounter in hindering us to solder successfully. The factors affecting the rate of reaction, phase change, and the concept of the heating curve is very much applicable in soldering. There are two main factors that can interfere with soldering. First is the regulation of heat. Soldering is greatly heat dependent as a high enough temperature is needed to melt the solder. The solder needs to heat up above the melting point to ensure a complete phase change from solid to liquid, which allows the metals to flow properly and create a proper solder joint. As temperature of the soldering iron increases, the solder would melt at a faster rate. However, worrying about the heat given off by the soldering iron is not enough. The total surface area from the tip of the soldering iron to the component you are soldering also has a lot to do with getting these metal alloys at a high enough temperature. As more surface area of the tip of the iron is in contact with the component, a greater heat transfer would occur, thus successfully reaching the needed temperature for melting. The usage of heat in this aspect mainly concerns the phase change from solid to liquid. Some of these concepts, however, overlap with the factors affecting the rate of reaction, namely temperature and surface area. However, the concept of the rate of reaction has a more direct role in soldering. The second main factor that can interfere with soldering is oxidation. The metals can react with the air, creating oxides. Oxides that formed have a different structure than the composition of the solder itself, which causes it to interfere with the proper joining of the metals. As the temperature of these metals increase to the point of melting, the increased heat encourages oxidation to take place at an even faster rate. The goal in soldering is to stop this chemical reaction from happening. The solution to this is to use the appropriate solder flux. The solder flux is applied onto the components to be soldered and acts as a barrier between the air and the molten metal to protect it against oxidation. It also aids in thermal transfer, and because of its acidic nature, it cleans the surface from contamination as well. Most modern solder already has a few amounts of flux in its core. However, the use of extra flux may be needed as it evaporates quickly. Now that we've discussed main points to consider behind the science in soldering, I would like to debunk a wrong hazardous concept associated with it. There is a white fume from soldering that many claims that you should not breathe in as you may get lead poisoning from it. Applying the concept of the heating curve clearly debunks this. Let's check the facts. Solder is mainly composed of 60% tin and 40% lead. Tin has a melting point of 231.9 C and a boiling point of 2604 C. Lead, on the other hand, has a melting point of 327.5 C and a boiling point of 1749 C. Based on the heating curve, a substance at a solid state has to be heated to a certain temperature to achieve melting point to allow transition into the liquid phase. Soldering only reaches temperatures enough for melting. Further heating would be required to reach the boiling point for a substance to reach gaseous phase. Clearly, soldering doesn't reach up into 1000 degrees Celsius for these metals to boil and turn into gas. The fumes emitted while soldering is caused by the soldering flux. This vaporizes at a significantly lower temperature. These fumes still pose its own threat to our health as these may irritate our eyes, skin, breathing, and it may cause headaches. You should still avoid breathing them in, but rest assured that you cannot get lead poisoning from it.